Welcome to free energy and work. So, if delta G is greater than 0, then work has to be supplied from the surroundings in order to drive the reaction, because it's non-spontaneous. In biological systems, they often use one spontaneous reaction to drive another non-spontaneous reaction. And these reactions are then coupled reactions. So, the energy required to drive most non-spontaneous reactions comes from the metabolism of foods. And so let's look at the oxidation of glucose. So here we have glucose, and we add oxygen, we make carbon dioxide and water, and we have then standard Gibbs energy change of negative 2,880 kilojoules per mole of glucose reactant. So, in this case then, the free energy released by glucose oxidation is used to convert low energy adenosine diphosphate, ADP, and inorganic phosphate into high energy adenosine triphosphate, ATP. And then when ATP is converted back into ADP, that energy is released and can be used to drive other reactions. And this is essentially this reaction of going from ATP back to ADP is how our bodies, our cells, drive most of the reactions that they do. So, let's play a game. Let's play the thermodynamics game. There are 4 rules to our game. First rule, you cannot win the game. Which means at this point, the best thing you can do is break even. The best thing you can do in the thermodynamics game is tie. The second rule is you can't break even. Now you will always lose the game. So now, the best thing for you to do is to stop playing the game. Just to quit. The third rule is you can't stop playing the game. You will always lose and you can't stop playing. Which means the best thing to do now is to not ever start playing the game in the first place. And rule 0 is you must play the game. You're constantly playing and losing the game. There is no way out. You can't ever win. You can't even break even. You can't stop playing, and you have to start playing the game. So, these rules are related to the 4 laws of thermodynamics. The first law of thermodynamics says energy is always conserved. You can't ever win the game. You can't ever get out more energy than you put in. The second law of thermodynamics says you can't even break even. You always have to increase the entropy of the universe. Which means some energy is always converted into entropy, usually in the form of heat, through random motion of molecules. The third law says that you can't stop playing the game. Right? You can't ever actually get to absolute 0. That's the only time that you could stop playing the game, but you can't. You'd have to be at absolute 0. You're always in thermal contact with with the surroundings. You can't ever totally isolate the system and the surroundings. There's always going to be energy passing back and forth between the system and the surroundings because you always have some contact there. And you must play the game. You can't ever stop. You always have something going on because you can't ever totally stop all the motion of the molecules. And this means that always you are losing the thermodynamics game. Every process that happens loses the thermodynamics game. Because the best we can possibly do is break even, but if a process is going to break even, it just doesn't happen. There's no driving force to get it to go. So every process that actually occurs increases the entropy of the universe, either in the system or the surroundings or in both. We can't ever win. So that was free energy and work, and a bonus thermodynamics game.